Let's take a look at some limits with logarithms. So remember, we saw this graph, just a reminder of what the graph of natural log of x, or log base b of x, looks like, is this. So from this, we can pull out some of our limits that we need. So the limit is x goes to infinity. When we go to the right really, really far, our function, remember, is just going to keep going up and up and up. It won't go up very fast, but it will slowly go up. So this is going to be infinity. As we go to 0 from the right, remember that's the notation of 0 from the right, we're going to be approaching negative infinity. And as we approach 0 from both sides, as we approach from the right, it's going to negative infinity. As we approach from the left, it does not exist. So this guy does not exist. So if we take a look now at this limits over here of what about as x goes to infinity of natural log of x over x. So if we take a look at this limit, remember we can ask the question, where does the top go, where does the bottom go? So the top, as x goes to infinity of natural log of x, we see that's going up to infinity. And then the denominator, this is also going to infinity. So we have infinity over infinity. That is an indeterminate form. So we don't know what the limit is. But what can we do to figure out the limit of an indeterminate form that's a fraction? Well, we have L'Hopital's rule. This is, when we saw L'Hopital's rule before, we only looked at powers of x's. L'Hopital's rule is not really that useful in those cases. It can be helpful, but this is where L'Hopital's rule becomes necessity. We need to use L'Hopital's rule here. So when I take a look at using L'Hopital's rule, I have the limit as x goes to infinity. Remember, L'Hopital's rule says I take the derivative of the top divided by the derivative of the bottom. The derivative of the top is 1 over x. The derivative of the bottom is 1. So when x goes to infinity, this whole expression goes to 0. So that is the limit. Now, what this means, so we never talked too much about limits of fractions intuitively. What we're saying is when x gets really large, which one is going to grow faster? If you have a fraction, is the top growing faster or is the bottom growing faster? If the top is growing faster, then you're going to keep getting numbers where the top is a little bit bigger than the denominator, and that's going to keep going up to infinity. So normally, if you have something like this, it'll go up to infinity. If the denominator is growing faster than the if the denominator is growing faster than the numerator, then you're going to keep getting a bigger and bigger denominator, and so that's going to make the whole thing go to 0. If the numerator is going around the same rate as the denominator, then what's happening is that you're going to be approaching a finite number. So what we're saying is that natural log of x grows slower than x. And if we visualize that, that makes sense. Because if we look at the function y equals x versus natural log of x, this y equals x is going to grow faster. We're going to get up to infinity much faster than we will with natural log of x. So this is one of the ways that they can show that. That's used a lot in various upper level classes. But just know L'Hopital's rule is used right now. Here, the limit as x approaches 0 from the right. As we approach natural log of x from the right, we see that goes to negative infinity. As we approach x, it's going to go to 0. So now we have the numerator is going to negative infinity, the bottom is going to 0. Now we have to figure out positive or negative 0. This is a positive 0. So is this an indeterminate form? Think about this. So if we're dividing by 0, or things getting closer to 0, the whole thing is going to infinity or negative infinity. The numerator is going to infinity as well. So this is going to go zooming to infinity or negative infinity. This is going to grow both of these in the same direction, going towards an infinity. Is it positive or negative? Well, because this is negative infinity, that's positive infinity, this whole thing goes to negative infinity. So be careful. Not every time you see infinities or zeros, you should be thinking indeterminate form. When we had a non-zero divided by 0, we were thinking something infinite. And indeed, on the top, when you have something like infinity, you're also thinking the same thing. So they work together to get negative infinity as your limit.